In this video, we're going to focus on a couple of miscellaneous topics first before we dive into any of the bigger ones like NTP, DHCP, and NAT. Because it's kind of one of those deals where if you don't have an idea as to what you're doing with things like logging and debugs or tracking and Netflow, they're not technically going to kill you if you don't know what you're doing. You can if you're like me, you've had to fudge your way through some configuration in production because you don't have access to the internet, or you've seen it done once or twice and you kind of had to figure it out as you go. So a couple of the first things we're going to take a look at is logging, and logging is actually really simple to work with. If you've done any time, if you've been on a box before, I'm assuming you have. If you haven't, and if you don't have the ability to virtualize like I do and things like that, I get asked a lot what my home lab looks like, and professionally I've been doing this stuff for almost 6 years, and I've spent a lot of money on my home lab, and I'm probably $5,000 or $7,000 I've got invested into it between all the routers and switches that I have, and now that I have gone, because I hold a VCP and data center virtualization, so I'm very familiar with VMware. So I run a VMware lab here at home, so I'm able to virtualize a lot of the things I do. So if you don't have the capability of doing that, or you don't have enough memory on your computer to support 10 iOS routers, which takes up about 2 gigs of RAM, you can run Packet Tracer for some of this stuff and play with it, like the Telnet, all the lower level stuff. This is more CCNA level detail, because the fact that, once you understand how Telnet and SSH works, that'll carry with you through your career. It doesn't matter what level certification you're going after, or if you even bother about going after certification. So we'll talk about logging, then we'll talk about getting into we'll talk about ICMP with SLAs and tracking, and then we'll talk about Netflow and how that all works, because each one of those is relatively easy to start off with, and they're all kind of miscellaneous topics. So we'll discuss those, and then we'll get into DHCP, NAT, and NTP as we go along here. So with syslog, if we actually go up to global config and then we exit, what you just saw pop up there at the bottom, this August 3rd at 22:15, which is the actual correct time, that's a syslog message. The syslog message is going to be a message that's generated at the console level. And it's a console specific thing. It won't pop up by default on a VTY connection unless you tell it to. And basically you have a couple different ways of looking at this. You have the date, the time, down to the millisecond. You have this guy right here is the most important information here. We have this is the facility, the level, and then what the issue is. So right now the system generated this message. It's a severity 5 alert, letting you know that something happened, which is typically just information. And then we have what it was. We have the configuration. Doesn't mean we actually did anything. It just means that somebody went into global config and then came out of global config. So that's how that would basically break down. So if you're concerned about that, don't worry about it. It's not that big of a deal. And you can specify in your config what level you what level you log to. So it's one of those things where you make sure you know what you're doing before you do it. So the basic idea here is, if we go to global config and we type in logging, did I just learn a new command? I did. Control Y? Oh, I like that. I just noticed that. I was like, I hit Control Y. So it repastes in what you just had. I kind of dig that command. So if we do a logging, click in here, logging, and you say logging console, and you specify what level, and you have your different levels in here and stuff like that. So these are your capabilities you have available to you. So that's where most of this is going to come into play. So you have different configuration levels and what you have the ability to do. So if I wanted to log debugs, I could do that, and that's going to let me log everything console related to that. You can also choose where you want to send the device. So if I have a logging server, which I do believe on my TFTP server, wherever it went, let's see if I can pull that back up. TFTP. I do have a syslog server. So what I'm going to do is I'm going to point this guy here. I'm going to directory. I have to point it to a different location. Let me just change this up real quick. I'm going to browse to documents, and then I'm going to say iOS. Where'd it go? Right there. So I'm going to say OK to that. I'm going to set the IP address to be this guy, and I'm going to come in here, and right now I have a syslog server. So I'm going to be able to point my config there, or I can do a log viewer. I can say, click here, and I can say logging host to 192.168.1.151, and I can say, I don't know if that's exactly if I'm in the right part of it here, but I can say exit. Not sure if it's actually going to. Oh, yep, there it goes. It says logging started. It kicked it out. Log viewer. On port 514, so that's how you would get this kicked off. So maybe it's syslog server. So it's now it's started. So let's go back to that and then drop out. See if that'll trigger it. I'm not sure if that's actually the log viewer. Not sure, to be honest with you, but at least you saw it here. So it would actually logging host. So we can also do logging host, and you can specify. Oh, the IP address is that, and you can say. No, you can't. But that's how it would actually break down. Now, local logging would be show log. This would be the show log. So now I can specify, what's going on here in the network. So I'm logging. This is my local logging that I've done so far today. So everything I've done so far. This is what I've got to show for it. So it's pretty straightforward for the most part in how this breaks down, but just making sure you know how to navigate around with what's going on is going to be the important part. So that's local logging and syslogs. The other one here is going to be debugging. Debugging is going to be one of those things where it's taking a background service or a background operation of some sort that would be happening that you wouldn't be able to see, like the OSPF adjacency negotiation, pings, and all the other stuff that goes on that you don't normally see, bringing them forward. So if I wanted to do a debug ICMP, and hit the enter button. If I wanted to ping 10.1.100.2, it's showing me the pings. So those are all pinging out. Everything looks good, right? So I have those pings. Everything is showing me that I've got going on here. There's one other thing called conditional debugging, and conditional debugging basically means if you have to set you can set a condition to debug against that condition, and if that condition is met, then you go ahead and debug for it. Pretty straightforward. So the next one thing we're going to talk about here is going to be timestamps, and obviously we can go to timestamp, go to config and type in logging timestamps. Is it timestamps? Service timestamps. Service timestamps log, and you can say date time, and you can say local time millisecond year. So we're going to type in local time, and you can say show time zone, and you can say down to the millisecond if you'd like, and then There. So now if I was to log out of here, and now it's giving me, I don't think it was giving me UTC before. It was not. Now it's giving me UTC. Universal Time Coordinated. Basically all that is basically Greenwich Mean Time, which is I think 5 hours ahead of me. Which is I think Greenwich England, I think is where it comes from. Which is like the 33rd parallel, I believe is what it is. So that doesn't make much of a difference. I'm actually 5 hours negative on UTC. So we have that. You can actually do this. You can type in no service timestamps, and you can turn off logging and debug. So if I typed in log, hit the enter key, and dropped out, my timestamp wouldn't show up. It would still show the syslog, but it would take the timing out. The other thing too is I can go in here, I could type in, hit the up arrow and pull that out, and I can say this, but I also can say service timestamps. No, service. Where is it here? Service timestamps. Service timestamps. Or is it in here? Counters. Service counters. Service. No, it's not that. It's let's see here. Where is it? Service time. I'm still looking for. Is it counters? Sequence numbers. There it is. Sequence numbers. Now, if I was to jump out here, it should indicate a sequence number. Now, I've got sequence numbers here, and that's going to help me break down. If you're sending syslog messages and you send them out to somewhere, if somebody goes in and deletes them, it'll show a separation in the number range they're equal to. So if you come up here and you go do this and then drop out again, it'll be 49. So it increments. So we have that. The other one that's in here is timestamps. Service timestamps. Service Naggle. Naggle basically is a congestion control algorithm for things like Telnet, because when you're dealing with Telnet, every character that you type in is one packet sent to the device. So if you go in there and type in service Naggle, it'll actually try to combine those individual packets into into one packet instead of sending every character as one packet. So it tries to clean up the connection. And the reason for that is because I don't know if you guys know this or not, but when you are sending traffic back and forth from you and the device, your connection to the router or that switch, that priority level for your service, that service that's responding to your commands, is actually very, very low on the priority list. Things like OSPF hellos and forwarding of IP traffic for data in the data plane are going to be much, much higher level than what the exec process would be for. The exec process actually has a very, very low level, or a very, very low priority. So it's not worth it to sit there and go, okay, well, it is what it is, and just, start forwarding traffic. So it'll actually prevent you from doing that. So that's logging. The next one I'm going to take a look at is going to be, we're going to take a look at ICMP SLAs. And basically, an SLA, basically at the end of the day, all that is you are pinging something, or you're doing, your SLA is a reachability verification, basically is what it breaks down to. So the idea here is, if you're pinging google.com, so you're pinging quad 8s all day long, your goal is that if you ping google.com, quad 8 all day long, every 5 seconds, if you lose connectivity to google.com to quad 8, then you're going to automatically fail over to your other connection after so many missed pings. Well, that's great and all, but a ping doesn't necessarily mean that the application's broke or working. So basically the idea here is, with an SLA, you can actually go out there and try to pull down an HTTP GET which would be the same thing as you going out to Google, out to the Google website and having the web browser do a get. So when you do an HTTP get to 8.8.8.8, it's actually trying to pull down the website of google.com. So it pulls that down, and that's much more reliable. And if it gets a positive where it effectively did pull it down, then you know the connection's still active, because layer 3 ping is 4 layers below the application. So when you and I open up a web browser to Google, that's a layer 7 action. Layer 3 just means you can reach it via ping, which isn't very reliable. Some other ones do. You could do a DNS Grab, I think, is one of the other ones. So in order to configure that, you would type in IP SLA, and you would type in this entry number, which is going to be 1, and then you hit the enter key. And from here, you would type in, we want to do an ICMP echo, and then the IP address is going to be 10.1.100.2. And then you're going to, from here, you would set the frequency is going to be, or I should say, the frequency is going to be once every second. The timeout will be, I believe it's milliseconds. We'll say is we'll say is 1,000 milliseconds for one or we'll say 5,000. We'll say the frequency is going to be 10 seconds, and then the threshold will be we'll say 5,000. I'm just kind of spitballing at this point, but that's the idea about how this would work. So the idea here is, now that I've set these values in here, I can exit out and I can type in I can do show IP SLA statistics and see that well, can I ping? Oh, I never scheduled it, sorry. So config T IP SLA schedule 1, and then we're going to say a start time of now and a lifetime of forever. Sorry, the config is off the top of my head. So here we are. We're pinging out to 10.100.2, and if we jump out here, we do a show IP SLA statistics. We'll see that it's okay. It's pinging every 5 seconds, or I'm sorry, every 10 seconds, and if there's a failure, then it will come back as a negative. So if we go to 2, we type in interface Ethernet 1/0, we type in shut. So it takes that down. We're going to go to 1, and then we should start to fail. And because it didn't respond, now we have a couple of fails. So we have one failure. I'm going to click on 2. I'm going to type in no shut. Bring that back up. So it's up. Our Ethernet connection comes up. So does our IPv6 connections, and so does our IPv4. We have that. Now we're back up. Now we're able to ping again. Right? Now if we do a show IP SLA statistics, we have good responses. Now what I'm going to do here is I'm going to implement tracking. I'm going to type in tracking. Let's say track. Object 1 is going to be IP, because we're going to be tracking an IP SLA. You could also do a list. You can also do a interface if you'd like to do as well. IP SLA 1, and you're going to say reachability, or that's all we have to do there. In tracking, you can go in here for more information if you'd like. But if we do a do show track, it says that it's okay because the the SLA state is up. So we have that. And then what you would do here is the tracking object is where you would apply to like a route map for like a default route if you wanted to. You could do a, we'll say we're going to go to, I don't know if we can do it under OSPF. Router OSPF1 default dash information originate. Always, and then we're going to say a route map of test. Test, and then we're going to exit out here and type in route dash map of test, and we're going to match. No, it's set. Actually, that's a really bad example. I apologize about that. Where you would actually do is you would track. So set IP next top. So say, for instance, set IP next top to whatever verify availability, and you're going to be 10.1.100.7, and then you would say insert sequence to insert. We're going to say 1 because we're going to be tracking, and then you would say sequence to insert into that, and then you would set track, and you would set track 1 to match that, and hit the enter key there. And as long as it's up, you'd be able to set the IP next top. But that's more or less for one of those things like policy routing. And I've already covered policy routing, so I'm not going to go any further into detail on that one, but that would be the example there. So that's how you would do that. Now if you were to type in track 2 and type in interface, and you want to track interface Ethernet 1/0, and you type in line protocol, that's going to be layer 2, where IP is layer 3, and hit the interface. You can say, as long as it's up, it's good. If it's down, it's bad. So show track 1, we're good. Show track 2, we're good. Both are up. So you can track multiple aspects of whatever you want. The last one we're going to take a look at is going to be with Netflow. Now, Netflow is kind of a unique bird because of the fact of the way that it works. So what we're going to do is we're going to take a look at doing Netflow. But what I actually need to do here with Netflow is I'm going to very quickly get a connection going between 7, 8, and 10. And I'll walk you through this config. I'm just going to configure the stuff. I'm not actually going to tell you what I'm going to do before I do it, because you've already seen me do OSPF, BGP configuration. All I'm going to do basically is I'm going to run through this config just to get the connections up and operational, so that when we do a Netflow, you can see what it would look like if we were to be tracking Netflow. So I'm going to go to router 7, and I'm going to go to show run pipe section BGP. And you'll see how fast. So I got BGP for IPv6 running. So what I'm going to do is I'm going to get BGP running between 7, 8, and 10, and I'm going to go as quickly as I can. So router BGP 1267, neighbor is 87.0.0.8 remote AS. And I'm going to go type on 8. I didn't turn off the I didn't turn off the command, so let's go to 7 real quick and make sure that's the correct IP address. Do show IP interface brief. Obviously. That's why it's not working. That should come up now, and we're typing no BGP default IPv4 unicast. And we're just typing address family IPv4 or IPv4, and we're going to type in redistribute connected. Get that out of the way. We're going to go to 8 real quick, and we're actually there already. And we're going to exit out and type neighbor of 108. Let's actually make sure that I have an address. So do show IP interface brief. I do. So neighbor of 108.0.0.2 remote AS of 10. Address family IPv4. in. I don't actually have to type that in twice. It's just force of habit. Exit out of here. Exit out of here. Do show IP interface brief. So router BGP 10. Alright, that gets me up. Do show IP route. There I had the route. So do ping 87.0.0.2. I can reach it. That's what I wanted to see. So there we have it. So now what we're going to do is we're going to go to router 7. I'm going to exit out of here. I'm going to type in IP flow, or actually type in interface Ethernet 1/0 and type in IP flow ingress, and interface serial 2/0 is IP flow egress. So we have our inbound and we have our outbound. So I'm also going to type in here is going to be exit out of here and type in IP flow top talkers, and we're going to say hit the enter key, and this is where we actually get to the fun stuff. So what I can do here is I can say we're going to match protocol. It's easier to say IP protocol, match protocol, and we're going to say is going to be TCP, and we can say and we also say protocol number. Say for instance we want to match protocol 1 would be ICMP for ping, match UDP for DHCP, things like that. So we're going to actually, let's do that actually too, is UDP. And we're actually going to get out of here. We're going to, sorry, that wasn't supposed to get out of there so early. And we're going to say, match source address, and we're going to say it's going to be 10.1.100.1/32, and then we're going to say match destination address of 108.0.0.2/32, and we're also going to match source port, or I'm sorry, match destination port of 80, and we're also going to match it 80 and 80. So that means we'll be able to open up a port. We could telnet to it if we wanted to, and the cache timeout is going to be, we'll say, is 10,000 milliseconds, which is 10,000, and we're going to sort by bytes, or yeah, bytes is fine, and then we'll say the top 10 talkers. So we have that. So now what we can do, we can exit out of here, and we can do a ping. So ping 10.1.1 or 108.0.0.2, and it's not going to work. And they're like, well, how do you know? Well, because the fact that if we were to do a trace route to 108.0.0.2, it doesn't know how to get there. So on router 7, I have to type in router OSPF 1, and type in default dash information originate always. And if I go back to router 1, I do a show IP route. Once it comes in, I should have a default route. Clear IP route star. Might take it a minute for it to propagate. Why is it not coming in? Clear IP OSPF process. So it'll bounce the neighbors. That should give me my connections back in. And well, once it comes back up, I still don't have a default route. Why is that? Show IP OSPF database. Alright. So anyway, let me just do this. IP route 10.1.100.7. Now I default route. So that's what I want to see. Now if I do a trace route to 108.0.0.2, I can get to router 7, but the problem is that I can't go any further than that. Now if I was to go to router 7 and I was to go to here and type in config t and type in under router BGP 1267 and type in address family, or type in network of 10. Address family IPv4 and type in network of 10.1.100.0 with a mask of /24. And then if I was to go to 1, sorry, I was able to reach it there. So I can get all the way there now. So if I was to go over to router 7 now, and jump out of here and do a show IP flow top talkers. Yeah, so right now there's no matching flows to match. But if I was to ping it though, ping 108.0.0.2, go to 7. Show run section IP flow. Oh, see, I see what happened. You can't choose multiple connections. I gotcha. IP flow top talkers, match protocol 1, and let's try that now. Go to 7 and type in do show IP flow top. Do show run pipe section IP flow. Or maybe I have to specify the port. Let's do on 7. It's match protocol. Sorry, match protocol TCP. We'll do a telnet, and we'll say telnet to 108.0.0.2, and let's make sure telnet here is good to go. We'll type in line VTY 0 space 4 login password Cisco, enable password is Cisco, and go back to 1 and hit the telnet. So there we go, we were able to open it. If we go to 7 and do a show IP flow top talkers. No, there's no top talkers. Well, normally it would show you this, and I'm not sure why it's not, but that would give you the idea of how that would work. Now if you wanted to export that, you could say, and what I'm just showing you here is local retrieval. If you were to set the IP flow export, and you would specify the destination would be the IP address that you want to send it to, which would be a collection station of some sort, and then you could say the source destination of 1.1.1.1, and then a source port of I think 9990. In fact, let me look that up real quick. let's go here. Netflow port 9996 or 2055. I've seen both 9996 or 2055. I think Cisco. According to some of their configuration, it can be pretty much anything. The most popular ones that are sitting here are 2055, 9995, and 9996. So you'd be able to choose any one of those. I've also seen 9990 as well. So it just depends on your configuration. I mean, you can change it however you'd like to, but yeah, at the end of the day, it really is up to you. So pretty much that's what I wanted to cover in this video. So yeah, that's pretty much everything for that. We're going to take a look at doing DHCP, NTP, and NAT, and we will be wrapping up. I hope this has been informative for you, and I'd like to thank you for viewing.